All right. Hi, everyone. We're jumping to observational studies and experiments. So this will be our last section on collecting data, and then we will move on to graphing and describing data. So just as a reminder, we covered this section in class, and I will post the notes to it in case you had to miss class for whatever reason. So for observational studies, we're going to start actually just by jumping into an example. And so let's suppose that we're interested in determining whether like getting a good night's rest, so maybe getting 8 or more hours of sleep, does that lead to better performance on a statistics exam? And so we're first going to design an observational study, then we're going to design an experiment to kind of try to answer this question, and then kind of talk about the advantages and disadvantages of each of those approaches. And so let's say that we're just interested in this Stat 113 class, and so we're going to use you all as subjects, and maybe we're going to look at performance on our first exam. And so for an observational study, we'll define it after our example, because the example I think is more clear, which I think is usually the case with stats. So in our example, we would do an observational study by maybe asking each student to write down how many hours of sleep they got the night before the exam. And so we have information now on how many hours of sleep each student got, and then we also record each student's score. All right, so this is observational. And so the definition of this is just that data is collected such that the collection process, so actually getting this data, doesn't really interfere with how the data arise. All right, so pretty much you're just collecting data. You're not manipulating anything. You're just recording students' sleep, and then you're recording their score. There's no sort of experimental manipulation like we'll see in the experiment section. Okay, and so advantages of this observational study approach is that it's often easier to collect data. You know, like if we actually wanted to carry out this study, it doesn't really seem that hard to do. Just asking the amount of sleep the night before. I'd grade your exams anyway, so we already have that component. It's also often cheaper, and it's often more ethical. And really when we're saying that, it's more ethical compared to an experiment. And so we'll get into that issue of ethics when we actually talk about experiments next. Disadvantages is that there's going to be a little bit less control. And the big disadvantage is that we can't infer causation through the observational study alone. So that's the huge, huge disadvantage, is that if we were to actually do this study and I saw that people that tended to get more sleep tended to do better on their exam, I can't really say that getting more sleep causes people to do better on their exam. And so that's a huge disadvantage because usually humans want to be able to make these types of causative conclusions. And so the reason we can't do that is because there could be confounding variables. And so a confounding variable we're just defining as a variable that is associated with the explanatory variable and so take a second to think about, like in this study, what would the explanatory variable actually be? Right? So yeah, so the explanatory variable in this case would probably be amount of sleep. And so we want a confounding variable is associated with that and is also associated, associated with the response. And so in this case, the response is exam score. Okay, so take a second to go ahead and pause the video and think about an example of a variable in this particular study that would be confounding. So whatever variable you think of would have to be associated with how much sleep a person got that night, and it would have to be associated with their exam score. Okay, so you could have thought of any number of examples. The one that I think of is kind of abstract, but it's like exam preparedness. And if I were to provide a reason for this, I would say because um, preparedness, let me reword this. So I might say because students who are more prepared would tend to get more sleep because they're already kind of prepped. So that's where it's associated with the explanatory variable and would also tend to score higher on the exam. So that's where it's associated with the response. So it's something that's associated with both. And so then if it's associated with both, we now aren't really sure, like, okay, well, is the sleep the cause of the better exam scores, or is it this exam preparedness? So students that are more prepared do better on the exam, and that's the real cause. It doesn't really have anything to do with sleep. So this is kind of a more difficult concept, I think, but it is really important. And so we'll have a couple videos to watch. And so the links to these I'll also put in kind of like the weekly checklist so that you have easy access to them. Or you could click on the PDF again, and the PDF links to the videos as well. So take a second to pause the video and watch just about the first minute of this TED Talk video, and then we'll spend a few seconds talking about it. Okay, so this TED Talk, this lady has this example, which I'll draw here so that we remember, where she says kind of ludicrously that the number of ice cream sales and the number of drownings have this positive relationship. And so she says, well, ice cream causes drownings, therefore we should ban ice cream and whatever, blah, 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 blah. And so then she goes on to say, well, you could think about what a confounding variable would be in that situation. And the confounding variable, the most obvious one, is actually nice weather. So nice weather is associated with our explanatory because ice cream sales tend to go up when the weather is nice. And it's associated with the response. So the number of drownings tend to go up when there's nicer weather. So we can't really say, even though there's this association between drownings and ice cream sales doesn't cause an increase in drowning. So kind of like a silly example, but I think it's nice and it's easy to remember. And so if you want to kind of argue causation in an observational study, you kind of need to do so using some sort of argument outside of statistics and outside of the study itself. And so I'll give you another second to go ahead and pause this video and watch this video from The Onion. Okay, and so I love The Onion. The Onion's like my favorite thing ever, and it's rare that they make a classroom appropriate video, but this one's pretty great. And so it's kind of the other extreme. So they're doing a ridiculous example for stab wounds leading to death in monkeys. Um, the idea being that you should be able to infer causation in that study because you have something outside of stats to kind of show it. And that you know that stab wounds cause bleeding and death. And so you know that from biology, so you should be able to argue that way without really using stats. So kind of the point of that is that if you infer causation from an observational study, you must use an argument outside of statistics. So maybe some biological argument or maybe some sort of mechanical argument, but it's got to be in addition to your observational study. Okay, 13 minutes, I failed. So we will pick up with the next video talking about the corresponding type of study you could collect data for this example on, and that would be an experiment.